Hello, children. Today's lesson is brought to you by this fuzzy sock. All right, get that out of there. All right, now we are going to do our do now here. The sad news is I already taped this video once. The only thing is it wasn't recording. So, start over. All right. So we're going to focus on the sine alpha plus beta. And we're basically going to use the formulas that you guys had yesterday. These two on top. That leaves us with sine alpha, cosine beta, plus cosine alpha, sine beta. Okay, this is this plus sign here. And then from above, we're going to use the alpha minus beta. So we're going sine alpha, cosine beta, minus cosine alpha, sine beta. All right. Still on the screen. Here we go. So our denominator is cosine alpha, cosine beta. If you look through, you'll see some things that are like terms. You'll see this cosine alpha sine beta matching but direct opposite. This one. So these are a cancel. These two are also a match, and there's one of them here and one of them here. That makes a grand total of 2 sine alpha cosine beta. Denominator is cosine alpha cosine beta, and since there's no plus signs or anything, this is perfectly normal. You can cancel the cosine betas, leaving you with 2 sine alpha divided by cosine alpha, and since they're the same variable, then we can let them turn into a 2 tan alpha. And it looks like our identity or our verification matches because the right hand side is 2 tan alpha. So moving on to our new material. So these formulas are all set. New formulas for today are middle of the page. They're pretty straightforward. They got tan of u plus v, and so you get tan of u plus tan v, and the u's and v's seem to always be in order. They don't travel. If this is plus, the top is plus. Opposite. Tan u minus tan v. If this is minus, and the bottom is opposite. So the only thing we're going to do now is go to exercise 1 and try this out. All right, so first, let's do tan u plus v. And so that is supposed to be tan u plus tan v from above. Just doing a little extra writing here today. Tan u times tan v. And then they actually give us the numbers to plug in for them. So we're going 1/3 plus 1/4 divided by 1 minus 1/3 times 1/4. And get your common denominators. 1/3 would become 4/12, and 1/4 would become 3/12, all divided by 1 minus 1/12. All right, so therefore that numerator is a 7/12. This denominator, remember a 1 is the same as 12 over 12. Take away 1/12, that's an 11/12. So that's a complex fraction. So do what you've always done and just state change flip. Flip this bottom up to a 12 over 11, so the 12s are out. Final answer, 7 over 11. And you're moving on. So this question not only asked us to find tan u plus v, we're going to have to redo it for tan of u minus v. Okay, so that means we're doing tan of u, and this time minus on top, tan v divided by 1 minus. Oops, sorry, that's going to be plus. Always opposite that one, so fix that please. Plus tan u, tan v. Alright, so same numbers. You're ending up with a 1/3 minus 1/4 this time, all over a 1 plus 1/3 times 1/4. Okay, get your common denominators. We're doing 4/12 minus 3/12. And in the denominator, we're going 1 plus 1/12. I'm probably close. All right, slide that over. All right, so in the numerator, we have 1/12 divided by 13/12. And you're going to do the same state change flip here. So we're going 12 over 13, cancel, cancel. Final answer, 1/13. All right, everything at the front page was pretty straightforward. The back page is pretty much going in reverse. So you should notice that in this setup, if you treat this 190 degrees as u and this 35 as v, then it looks exactly like the tan u plus v scenario. Well, if that's the case, and that's u, how about we put the 190 where u is and the 35 where v is? So they're really asking us, what is tan of 190 plus 35? Well, I know 190 plus 35 is just 225 degrees. Now the tan of 225 degrees, remember, tan is sine over cosine. So that means I gotta be in quadrant 3, and I gotta know the sine, which is negative radical 2 over 2, and the cosine, which is also negative radical 2 over 2. If those things were divided, you would end up getting 1. Now figuring out the tan pretty much takes that much thought. So what I did for you guys is I put this graphic in the middle, and not only has it reminded you of all the cosines and sines all the way around the circle, there's an extra number, a third number. So this 0, that's the tangent of 0 degrees. This radical 3 over 3, that's the tangent of 30 degrees, or pi 6. So every single one of these extra numbers, this is undefined because you can't divide by 0. Tangent there, that's the tangent of 135 degrees, that's the tangent of 150. So all of these are going to be very, very helpful in doing your homework. This one is undefined because you can't divide by 0. This is negative. Radical 3, negative 1, and that's a negative as well. Okay, so these are very helpful for tonight's homework or classwork. Well, whatever you want to call it. All right, so let's go over here to part B. Very similar to A, except instead of working in degrees, they are working in radians. So if that's u and that's v, this looks like it's the tan of u minus v scenario. So let's just put the stuff in there. Tan of 5 pi 12ths minus pi 4ths. Get your common denominators. I'm going to go with 3 pi 12ths. Alright, so tan of 2 pi 12ths, and reduce reduce the fraction part. So tan of pi sixth. Now you can do it the long way. You can actually figure out that the sine is a half and the cosine is radical 3 over 2. State change, flip it, rationalize your denominator. Or you can go down on the graphic and go pi 6, radical 3 over 3. That's how I'm doing it. All right, so move on to exercise 3, bottom of the page. Here we go. Find the exact value of 255 degrees. That is not one of our common angles that exist on this unit circle. But if I think of two angles that can add to it or subtract to it, then I've got something. So, tan of 225 degrees plus 30. Now that is on our unit circle, and that's on our unit circle too. There are other things that are on a unit circle. You don't have to use 225 and 30. As long as you add the 255 or subtract to get a 255, you can do this. Therefore, we will say from the front of the page, that means we're going to do tan of 225 plus tan 30. And in the denominator, it's going to be 1 minus tan 225 tan 30. Okay, so the tan of 225, again, we still see it on the circle, is 1. Tan of 30 is radical 3 over 3. And in the bottom, you're going to end up with 1 minus 1 multiplied by radical 3 over 3. All right, so I'm pretty much out of room here. So I'm going to get a common denominator, put this together. Remember that 1 is the same as 3 over 3. So let's bring it over here. I'm going to say 3 plus radical 3. That's this numerator changed into this. This denominator will be very similar, except that 3 over 3 followed by a minus, so it's going to be 3 minus radical 3 over 3. So this is ugly as ever, but that is a complex fraction. So we're going to change to multiply. I'm going to flip this bottom up. So 3 over 3 minus radical 3. So naturally those cancel diagonally, and you would think that we are at the answer. But I'm going to tell you that your book never leaves a radical in the denominator, so they won't offer this as the answer. They're going to have to rationalize this by multiplying by the conjugate. So if it's 3 minus radical 3, the conjugate is 3 plus radical 3. So we're just doing FOILs now with numbers. We got nothing else to do, guys. Come on. So in the denominator, the FOIL is going to be from the first, I get 9. The outers and inners cancel. And from the last, I get minus 3. The FOIL in the top is going to be a 9. The outers are 3 radical 3. The inners are 3 radical 3. Adds the 6 radical 3. And the last, radical 3 times radical 3 is 3. All right, so we are almost there. Okay, so this 9 and this 3 is 12. Plus 6 radical 3. The denominator is just 6. And to get your final answer, you can divide both of these pieces by 6. So you're going to end up with 2 plus 1 radical